Okay, so I don't have a real name for it, so I just call it Geyser Controller. But to begin with, this is a typical device that you will see on your geysers. It's right in front of you, and this is what controls the gas supply to the geyser, water geyser that's mostly used in Pakistan. And you rotate it and set it to a particular temperature, and then actually there's a bimetallic strip inside it, and depending when the temperature is reached, the connection is made or not made, and then the gas supply is turned on or off. The problem with this device is the following: it does not know the time of the day. For example, to give you an example, let's say think about time between midnight and 6 a.m. in the morning when you don't need hot water. So what is this device doing? What it's doing is it brings the water to a particular temperature, and then it shuts itself off, and then the outside air cools the water down. And then this cycle repeats, and this cycle repeats, right? So between 12 and 6 in the morning, you're wasting a lot of natural gas, which is, of course, shows up on your gas bill and is also not eco-friendly. So we had a very simple idea. We made this little device, and what it does is that it snaps onto this controller. So the idea is very simple. Idea is that there is actually a small electric motor inside this device, and you can see this green strip, which is actually a microcontroller circuit, and that microcontroller circuit actually controls that motor. So what you can do is that this whole apparatus works on a real-time clock, meaning that it's time aware. It, for example, knows right now that it's almost 3:15 p.m. And using a phone, and we'll give you a more detailed demo later, you can actually give it a schedule. For example, you could say that at 6 a.m. in the morning, turn on the geyser at full, and by 10 a.m. in the morning, everybody's gone to their work or college or university or whatever, and your household is empty. So at 10 o'clock, shut it down. Right? I mean, the typical usage that we have seen is that when we have actually deployed it in the field, and when you look at the people's schedule, normally people would like to have their geysers turned on for about 8 to 10 hours a day. So just imagine, before that, for 24 hours your geyser was turned on, and now it's only turned on for 10 hours. So you can sort of see the kind of savings that you will get. And one of the questions that I kept being asked again and again is that we have instant geysers and all that, and the thing to realize is that we have estimated the install base of existing geysers in Pakistan to be between 4 to 6 million geysers, and those are not going away, right? And so this is a convenient way to actually enable those geysers to start to save a lot of energy. To tell you the truth, there's no government support in it so far, although we are thinking of applying for a grant now from ICT R&D Fund, and we'll see how that works out, because we now need to take it into production. So far, it has been a labor of love. It's a project that I've done on the side. I'm a software professional, but my first degree is electrical engineering. So this is something that I had to do, and this is a problem that we realized a few years back, and we've been working on it for the past year and a half now. It's me, another good friend, Dr. Farooq Kamran of Care and Case in Islamabad, and then we have a bunch of young engineers who have been working on it. And more importantly, we actually also engaged an industrial designer, Jamal Hamid, who's an ex-NCA professor, who actually designed the whole mechanical part of it. And the reason I say that is because there are 3 or 4 very distinct technologies that you have to be very good at to make this thing work. For example, one is just the casing itself, right? I mean, the mechanical part has to be just perfect. The motors needs to turn at the right time. The gears don't need to snap off. When it works in real life, it has to be waterproof, right? Because it's going to be outside, and there's weather element. So that's the part that an industrial designer does very well, right? So that is that. And then the second part was actually making the whole microcontroller circuit board. So that's sort of embedded system, right? So this literally is an embedded board which has its own little operating system running on top of it, and it's actually a Texas Instrument microcontroller that controls the whole device. So that is sort of hardware design, right? And once you have that hardware design, the third technology that needs to go in there is actually embedded programming, right? So that's third piece of nifty technology, and then the fourth technology that we need to use on top of that is that we actually have an application What you do is, you take an Android phone which has Bluetooth Low Energy, which is the BLE 4.0 standard, and as long as it supports that, you'll be able to program your Geyser controller with this. And by the way, an iPhone can also program it, and we are working on the iPhone version of it. So my point is that one of the things that we have learned is, and we are aware of this, but it has been a while since I've designed some piece of hardware, and I've been acutely reminded again, is that to do something which you can put it in real life has a lot of moving parts to it, right? I mean, as I said, you need 4 very distinct areas of expertise and bring them together to make it work. So literally, we have put in about $750,000 rupees of our own money into it, and that doesn't account for a lot of free time that has gone into it. This is just the actual cash that we have burnt, doing prototyping. Another thing that we have learned is that you have to do it again and again. This is the 3rd iteration of the design, and people think that you'll get it right for the very first time, and it doesn't happen that way. I think one of the things that I want to say very proudly is that when I show this device to people, one of the first comments that people make is this made in Korea or is this made in Taiwan? But at the same time, there are a lot of challenges because our workforce is not very trained, and you ask them to make a shaft which is 5 millimeters, and when you get it back, it's 4.9 mm or it's 5.1 mm, and there are a lot of challenges that people don't need. You give them a drawing, and our technicians who are working these CNC machines, they can't sometimes read those correctly. So there's a lot of time that we spent with them, but finally we have got it to a point where it's manufacturable, it's doable. We have installed about 10 units of this. Another 30 units will be installed within the next couple of weeks. So that's the goal, and I'm hoping that at some point we'll have a large enough of an order of this that we can really demonstrate the value. But so far, the response has been very, very positive. Well, this one, I mean, people ask me, this one we are selling for 4,700 rupees, and the reason for that is that this case alone is handmade, right? And it's literally made by taking these pieces that we cut from a lathe machine and put them together using by hand, which can take up to a day and a half just to make one of these cases. And this can literally be done in 5 minutes. The price that we want this to sell for is about 2,700 rupees at the end of the day. And that, in our estimation, you can recover in a month's time on your geyser bill. If you have one geyser and you're running it at a fairly high temperature, which we do in winter time, you can recover the cost of this device for in less than a month. So the ROI is just unbeatable. Pakistan is big enough of a market to tell you the truth. I mean, right now we are not even looking outside, but people have already approached us. I mean, once we get this perfected, there are other dimensions in which we can operate, right? I mean, there's already, I mean, we actually started doing this for home market, right, for the consumer market, but there has been a lot of interest from industrial concerns. For example, there is a textile factory where we had some people that we knew, and when we told them about it, they got really excited, right? They said, well, we have hundreds of these geysers in our staff colony and at our plant, and we would love to reduce our gas bill by half. And then they said, we want 3 of these, and we'll do a trial, which we are actually going to do next week. And if they like it, they would like to buy 100 of these. Actually, to tell you the truth, some people have attempted this as a final year project. I actually met somebody, I ran into somebody, and they said he actually attempted this in 1994. I think it goes back to what I said before. People, when they try to solve a problem, they have a skill set in one area, but they don't necessarily have a skill set in another area. And he said, frankly, I'm an electronics engineer, and we did the electronics very, very well, but mechanically we could not, just put it together. Right, and I think that's very, very important. And I think another name for that is cross-disciplinary. But unless you have a multi-dimensional team, which has many different skill set, it doesn't happen. And that's, I think, the key lesson that we learned, and I think a lot of other people can learn from it. We're trying to produce stuff that actually works in real life. All right, so it's very simple. Here's actually the way when you receive the device. It's like this. There's a protective shield which protects it from water if it rains and stuff. So we just take it off. One battery is already in there, and we put in another battery, And by the way, this battery will last you about a couple of months because people ask me that question. And then what I do is I launch my my application. Here's my little application, and I don't know how much you can see, but there is, it has detected that I have a controller. I'm going to say at 333 you make it 1/2, and at 334 we make it full, and at 335 we shut it off. Next minute, I want it to be half, then next minute full, and then the following next minute I want it to turn off. It zeroes itself and then it turns back, turns back on to the desired position. So let's see what it does at 334. Here you go. Resets itself to 0, okay? And because you might move it yourself manually, so it resets itself to 0, and then it brings it back to the desired position, when at the right time.